All right. Thank you, everybody, for coming. We appreciate you being here. And today, I want to talk to you about profound differences between voice user interface design and graphical user interface design. So profound differences in VUI versus GUI. Now, the reason that we're interested in this at Pulse Labs, and the reason why I think a lot of the people in this room are interested in this, is we think that conversational design and that voice user interfaces are going to be a huge deal in the way that human beings interact with technology for the foreseeable future. The world isn't going to necessarily be voice only, but it's going to be voice also. And it's going to be how you interact not just with your smart speakers and your phones, but also with your car, with your refrigerators, with your telephones, with your televisions. Everywhere, if you want to interact with technology, voice is going to be the most natural way and the easiest way to do it. However, there are some very fundamental ideas in visual design that are actually not applicable to voice design and are, in some instances, completely inverted. And so designers that are coming from primarily a visual medium like web and mobile can sometimes have difficulty adapting to voice. And in our testing, what we frequently see is that concepts and ideas that come from visual design they attempt to port it directly over into voice, and this has some unappealing consequences for the end user. So what are some core ideas in visual design? Well, in visual design, user input is constrained. You can make sure that you limit what people can see and what they can click on. Data can be presented simultaneously. You can have many different data points presented at the same time. Data is persistent. It can stay there for as long as you want or as long as your user wants. And finally, text input is hard. You've got to type it out, and making that easy was one of the fundamental improvements behind a visual user interface. All right. Well, how about voice? Well, in voice, user input is unconstrained. People can say whatever they want. Data is presented sequentially. There's an order in which people speak and in which responses are given. This presentation is ephemeral. Once it's spoken, it's no longer there. And text input is as easy as it can possibly be. All you have to do is speak. So in this talk, I'm going to talk about 3 important principles in voice design. And these are actually adapted from a talk that I gave with Paul Cutzinger. So you'll find these principles also in some of the work that he's done with Amazon. I'm going to talk about how they apply to voice. And also, I'm going to give some examples of how we've seen these principles not applied in bad designs that we've tested at Pulse Labs. So the first principle is that you need to be adaptable. In other words, you need to let users speak in their own words. Now, as I mentioned, in visual design, what users can do can be constrained. For something as simple as a yes or no, you can just give them a big green yes button, a big red no button, and if all you see are these options, there aren't a lot of possible user inputs. However, in voice design, even something as simple as a yes, well, someone can say yes, they can say yeah, they can say uh-huh, they can say sure, they can say why not. And any of these inputs need to be understood and treated the same way by a well-designed voice application. Similarly, people have many ways of saying exactly the same thing. So if you want to talk about a cat, you can say a cat, you can say a tabby, you can say a kitty, you can even say a grimalkin. And all of these should be understood as being the same thing fundamentally by a well-designed voice application. All right, so as an example that we tested a while ago of a skill that sort of failed to follow this principle, or that could use some improvement in following this principle, I'm going to show you here. And I want to just point out that although these are real examples from real tests that we did, the audio has been changed for anonymity's sake, so to protect the innocent and the guilty. So you'll hear me speaking, and then you'll just hear a poly voice respond.
What are you drinking?
Whiskey.
All right. Bartender, the good stuff.
That's a great response. It understood what the person said and responded appropriately. However, getting back to the synonym example,
What are you drinking?
Johnny Walker.
Never heard of that. I'll have my usual.
it's a strange bartender that has never heard of Johnny Walker. So any brand of whiskey in a well-designed skill should also be understood as mapping to the same input as whiskey. All right, the next principle here is this idea that you need to be contextual. In other words, you want to do as best as you can to individualize your entire interaction. Anytime we speak to somebody, you're having an individualized interaction with and for that other individual. So we've spent our entire life in dialogue that has been individualized to us. And well-designed voice applications should, as close as possible, attempt to mimic that. Even in something as simple as a greeting, people aren't going to say the same thing every time you meet them. They're going to say hi, hey, hello, how's it going? And so this element of, randomness, or not necessarily randomness, but individualization, is going to be important even in something as simple as a greeting in a voice application. However, I mentioned random, that can be dangerous. Simply randomizing your interaction and saying, okay, that's going to individualize it, can lead to some unfortunate interactions like the one here.
Give me a trivia question.
True or false? An orange has more vitamin C than a cup of strawberries.
How many think true? No, just kidding.
False.
Well done. You get an A+ on vitamin C. Would you like another question?
No, thank you.
Too tough? Okay.
So too tough is a randomized response to the person saying no, but it really, really doesn't make sense in the context of someone that just got a hard trivia question right. And so a well-designed trivia voice application should contextualize that interaction to be aware of what the person has done so far and make sure responses are appropriate. A skill that does a very good job of doing this is Jeopardy. So a successful quiz skill like Jeopardy is going to, for example, store your scores from your previous games. It's going to know what your score is for that game. It's going to store when you've played it last and when you've played it, how frequently you've played it in the past. And it's going to use all of those to individualize the interaction to you. Now, the final important principle that I want to talk about, and it's perhaps the situation in which voice design differs most profoundly from visual design, can be encapsulated in this idea that you want to be available. In other words, you want to keep all of your interactions top level. Now, this is not the case with visual design. So nested menus can make a lot of sense in visual design, but that's because, as I mentioned earlier, data can be presented persistently and simultaneously. Also, you can't present everything to somebody at once, or it just overwhelms the field of view and can be confusing and difficult. However, in voice, those constraints that make a nested menu a good idea in visual design, and those properties that make it easy to use, aren't there. And so with voice, you want to have a wide, top-level UI where you should be available to do essentially anything your user wants to do at any given point in that interaction. One example where this wasn't followed was a ticket ordering skill that we tested, in which we saw the following interaction.
Find a movie near me.
You can browse movies that are coming soon, or I can give a recommendation. What would you like to do?
Find A Wrinkle in Time.
You are in the browse movie section. Say stop to return to main menu.
All right, wouldn't it be nice if when the user said find a wrinkle in time, the quiz or the skill would just find a wrinkle in time and not ask them to first go back to the top menu, select an entirely different option, and then bring up their movie? Another example that we saw was in a food reordering skill for a major restaurant in which we saw the following interaction.
You can place this order or change something. Which would you like?
Change the location.
I'm sorry, I didn't quite understand. You can place this order or change something. Which would you like?
Change something.
Okay, you can change the pickup time, change the location, change the pickup method, or change the order item. What would you like to do?
Change the location.
In visual design, it makes a lot of sense to first have change something and then pick change the location. But in voice design, if somebody asks to change the location, you should just let them do it, as compared to first insisting that they specify they want to change something, and then specifying then what that something happens to be. All right. So these were examples that we experienced in testing of our own. And I want to talk just a little bit here at the end about how we got that data and what Pulse Labs does. So Pulse Labs is an Amazon and Google-funded company specializing in testing for developers and designers of voice applications. So we've tested skills and applications for over 150 brands in the last year. We handle all the UX testing for Amazon's Alexa Managed Partner Program. And if you have a skill that you're building, we'd love to do testing for you. We actually have a platform that you can use for free if you want to test with your own set of testers. So you can check all of that out at pulselabs.ai. If you have any questions about it, you can just send me an email at dylan@pulselabs.ai. And I look forward to checking out and testing and working with you to build great skills that follow those principles. Thank you.